Hi friends, this is the final part of the tutorial. I will show you to make a blockchain in R. So I have opened R Studio. So the first thing is I have set the working directory. Then I clear the memory space by rm and gc function. So the first step is I import libraries. Now I have used the digest library. So if you remember, this digest is used for hashing. So I import the digest library. Now create a sample block using the R object list. The name of the sample block is block example. Now if you see the contents of block example, it is index 1, the timestamp, the data, previous hash is 0, some arbitrary proof value, and new hash is null. So this part, the first part of the code is we created a sample block. Now we need to hash. So to hash the block, I've written a function, and the function name is hash block, passing the input block, and then passing this block to the digest function with SHA-256 hash generator, which will generate a 256 bit or 32 byte unique encrypted signature for your for the block, and then it will return the block. So let me run this function. Now the third step is I have written a function for proof of work. The name of the function is proof of work. Now this function takes the input argument as last proof. Now this last proof will be the previous block's proof value, which we are taking as argument, and then incrementing that value and assigning it to proof, and from there do some computation until this particular condition is satisfied. That is, that value, check if it is divisible by 99, and also check if that value is divisible by last proof. If that is the case, then return that value, or else increment that value and try to find that number. So this particular piece of code is for your proof of work mechanism or proof of work algorithm. Then we need to add the new block. So whenever a new block is created, that block is created with the proof of work and hashing it, so that all this two, that is proof of work and hashing, that I've shown, I've written the function for those particular things, will be called whenever a new block is generated. So writing a function for new generation of new block, that is gen new block, taking the argument as your previous block, then doing the proof of work by calling that proof of work function and returning that new proof for your new block, and then creating the new block, and then hashing that new block and returning the hashed new block. So this particular function generates a new block with proof of work and hash and hashing it. Let me run that. Then the next step is we define a genesis block or a special block that is the starting of your blockchain. So here define a genesis block with index 1 and some arbitrary previous hash. So this I've created a block genesis using the R object list. I have the data for that particular genesis block is genesis block with the timestamp and index 1 and arbitrary previous hash, that is 0, and some random proof. So let me create this genesis block. Then the final step is we need to build the blockchain. So now you can start building the blockchain. So we start with the genesis block and then add a few blocks using the loop. So using the R object list, with the starting as your genesis block, we create the blockchain. So if you see, the genesis block becomes the first block of your blockchain. Now for the next consecutive block, your genesis block becomes the previous block. So any block that is added next, your genesis block will become that previous block for that particular next block. Then define the variable taking the number of blocks that you need to add after the genesis block. So number of blocks to add, I've mentioned as 10 blocks, and then add blocks to the chain, iterating over the loop and calling the generate new block function. And this generate new block, whenever the new block is generated, the proof of work is also done and the hashing of that generated new block is also done, and then that block is added to the blockchain at the respective index, and the every next generated block is linked to the previous hash of the block and added to the previous block, and then that particular block indexes that is added is printed with the proof value and the hash value. could not find the function proof of work. So I will run the proof of work function, and then run this particular piece of code again. So now you can see block 2 has been added. The block with the index that has been added, generated, the proof value that is generated, and the hash. Then the genesis block becomes the previous block for block 2. Then for block 3, block 2 is the previous block. With the respective proof value, that is some computation. So here we have done that computation to find that particular number that satisfies our proof of work algorithm condition and the hash. So you can see that along with genesis block 10 blocks are added. So you have, after the genesis block, there are 10 blocks that is added to the chain. So for cryptocurrencies like Bitcoin, this would be a problem, as time to create a new block should be more or less constant. So now in case of Bitcoin, the time is around 10 minutes, because say if your proof of mechanism is taking too long to create a block, then that is also not a valid case. So this proof of work has to be continuously adjusted to keeping in mind the effort or the computation power and the speed it takes, and the varying number of miners in the network at a given time. So we said that this blockchain is a distributed architecture, so there are different number of nodes. So with varying number of miners in the network, if this proof of work takes very long time and is not constant, then it becomes, that case is also invalid. So therefore the difficulty of proof of work has to be adjusted continuously to make this creation of block along with hashing more in a more or less constant fashion, right? And then finally, after we created the block and we iterated over the loop, let's see how this one block in the chain looks like. So let's see the third block. So if you see the third block, see it says that it is the block 3 with the timestamp. The data says this is block 3. The previous hash is the hash of block 2, and then the returned value by proof of work function and the new hash of that block 3. So you can see, say if you will see block chain, say I want to see 9. So says that index is 9, the timestamp when the block is created, the data, this is block 9, The previous hash is the hash of block 8. The return proof of value number that satisfies the condition done for some computation, and the new hash of that particular block 9. So this entire code is available on the GitHub page. I hope I have kept this session very simple and try to explain how to create a blockchain, just to understand the ideology and the concepts behind this blockchain technology. You can check my GitHub page. Thank you for watching.